We are on the section 4.3, graphing with intercepts. We are learning second thing in this class. First thing was what? Solving linear equations, right? Second thing we are learning is what? Graphing linear equations. So for the last section, 4.2, we were doing graphing a line, graphing with what? A t-table, right? With how many points? 3 points, right? So now we are going to graph with special kinds and call what? Intercepts. Let's see, we're still doing the t-table, but with these 2 points, okay? Not any 2 points. These 2 points are what? Intercepts, okay? So before we can graph it with the intercepts, we have to know what are they? What do we mean by intercepts? So we have to identify them first. And where do you hear intercepts all the time? Football, right? When people play the football, the ball through that way, and the person will intercept the ball, right? If ball goes that way. So we are going to talk about intercepts, not any intercepts. We are going to talk about x-intercept and y-intercept. So what do we mean by intercept? That means if the line goes certain way, right? If the line goes this way, then something intercepted, right? So if it's intercepted by x, like this point, we will call it what? X-intercept, right? If it is intercepted by the y-axis, we will call this point what? Y-intercept, right? So let's take a look at the example we have. It says what? Negative 3x plus 5y equals 15. Okay? Do I have a linear equation? Do I have a standard form? Yes, because x and y are on the same side of the equation. So, take a look. If I want to intercept, I want the line intercepted by the x-axis. Look at this point. Okay, let's take a look. If I put x equals 0, what do I have? I have 5y, right? Let's just write the whole thing. Negative 3 times 0 plus 5y equals 15, right? Then this is 0. Then y will be what? 5y is a 15, y is 3, right? So x is 0, y is 3. So that means what? I have 3 x and y, right? 0, 3. Where is 0, 3? That would be 0, 3, right here, right? 0, 3. Okay? If I have y is 0, see what happened? y is 0, I will have negative 3x plus 5 times 0 is 15. So negative 3x is 15. X is what? Negative 5. Right? So that means when y is 0, x is negative 5. So how does it look like? That would be this point, right? Is that right? Negative 5, 0. Right? So if for this line, negative 3x plus 5y, it will cross the y-axis here. Cross y-axis at this point. Cross what? X-axis at this point. So for this graph, what do you think? Which one is x-intercept? X-intercepted by x-axis. Right? That would be x-intercept would be what? Negative 5, 0. Is that right? Then what is your y-intercept? The line is intercepted by y-axis. So it's here. So that will be 0, 3. Right? So for this equation, we have x-intercept and y-intercept. So if we use t-table, x and y, so for x-intercept, take a look, x-intercept, which one is 0? Y is 0. So for x-intercept, y is 0. For y-intercept, which one is 0? X is 0. So it's the opposite. Okay? So this one will be negative 5. This is a 3. So first, we identify intercepts by doing what? If I have an equation and given, right? If I want to find the x-intercept, what would I do? I would set y is 0. If I want to find what? Y-intercept, what would I do? I would set x is 0 to find what? Y-intercept. If I set y is 0, I will find what? X-intercept. So it's the opposite. Okay? So on your paper, page 23 on the top, and that's the equation, right? Then that's your x-intercept and y-intercept. So we say to find the y-intercept, okay, which is what? Intercept by y-axis. Then we will set x is 0, right? For x-intercept, it's opposite. We will intercept by x-axis, but we will set as opposite, set the y equals 0. Right? So then in general, you will say this way. To find the x-intercept, to find x-intercept, we will let what? See, x-intercept, we will let y is 0 and solve for x. Right? We let y is 0, then we solve for x, then we find what? X-intercept. Right? If we want to find y-intercept, what do? We will let x is 0 and we will let x is 0, then solve for y, then we will find what? Y-intercept. Right? In a way, we do this way. We will use t-table. Okay, we will put the x0, y0. Then for x is 0, we try to find the what? Solve for y intercept. Then let the y be 0. Then we will solve for x for x intercept. Right? This way we can find the 2 points on the line which are special 2 points, not any 2 points. Then once we have 2 points, then we can do the graph, right? So second method we are going to use is what? Graphing a line with what? T-table with special 2 points called what? Intercepts. First one we did earlier is what? T-table with 3 points, right? Like 1, 0, 1, 2 or 0, 2, 4, those 3 points to do it in general. Then second method we are doing is using what? Special 2 points for a purpose. Okay, so let's learn that. So first we have to know how to identify the intercepts first. Then we will use the concepts of intercepts 0, 0 and to find the special 2 points for graphing a line. Right? So let's first identify them. Okay? So look at the page, where is it? Page 27. Let's identify them first. Take a look on your page 27. So you have this one, right? Here is -4. Here is what? 3. So what do you think? What's your x-intercept and y-intercept? X-intercept is this guy, right? -4. But usually we use what? The ordered pair to describe the point. So x-intercept will be what? -4 and 0, right? Then your y-intercept will be this one, will be what? 0, 3. Is that right? So that's your page. We are on the page 27, right? So let's identify them first. And second one is like this. So how many x-intercept you think you have? How many intercepts you have? And how many y-intercepts you have? So 2 x-intercepts, 1 y-intercept. So here is -3 and 3, here is 5. So what's your x-intercepts? See, so you will do -3 and 0 and what? 3 and 0, right? Then for your y-intercept, that will be this guy. Order the pair, you will use what? 0, 5. Right? Let's look at the next one. We have, which is like this. So we have this one. So you curved over and this, right? So here is what? -1, here is -4. The top is 4. This one is what? 1. So how many x-intercepts you think you have? 1, 2, 3, right? 3 x-intercepts. And how many y-intercepts you have? Just 1. So how do you describe your x-intercepts? That will be -4, 0, -1, 0, and 1, 0. right? Then what's your y-intercept? So that would be 0, 4, right? Look at the next one. It looks like this, an ellipse. Here is a -3, 3, -2, and 2. So how many x-intercepts we have? 2. How many y-intercepts we have? 2, right? So how would you write the coordinate for the x-intercepts? So that would be -3, 0, and what? 3, 0. What's the y-intercept? That would be what? 2, oops, not 2, 0. 0, 2, and 0, -2. Okay? So when you do the problems, sometimes you will mingle your x and y and get a little bit dyslexic. Okay? It happens. So just pay attention to it. Okay? So what did we just talk about? We talk about x-intercepts, y-intercepts, right? How to identify them. Okay, we are going to use intercepts to graph a line. So, let's see a few examples. First one, right? The second one, we have this. And another one, we have this. Three different equations, right? So, are those all linear equations? Yes. Okay. And first one a standard form? Yes. Second one? No. The third one? No. But it doesn't matter. We can all use what? Intercepts to graph the line, right? So for this one, we say you use 0. For x, you find the y. That means what? For y-intercept. Then you use y0 to find what? X-intercept, right? So when x is 0, what do we have? When x is 0, we have 0 minus 3y equals 6, right? Then what's your y divided by -3? Y is what? -2, right? So we have a 1 point is 0, -2, right? 1 point. Then another point is when y is 0. So y is 0, you plug in x minus 3 times 0 equals 6. So what's your x? X is 6, right? So that will be 1, 2, 3, 4, 5, 6. Mark your point. So then you connect 2 points. Then that will be your line, right? Let's look at the next one. So next one, y is -2. So we do the t-chart, right, with 0, 0. So when x is 0, what's your y? So x is 0, so y equals -2 times 0. So that would be 0, right? So that would be your point. 0, 0. And next one, when y is 0, y is 0. Then you have 0 equals to negative 2x. Then you divide it by negative 2. What's your x? It's still 0, right? Can you make a line just with 1 point? You cannot. So what do? Try to find another point, right? So 1, if x is 1, so what do you have? Y is negative 2 times 1. That would be what? Negative 2. So 1 and negative 2. Right? So you can graph a line. You need at least 2 points to graph a line, right? That's why when we studied in section 4.2, it says the first method we used was what? We use t-table. So that's your method 1, right? So use t-table with how many points? 3 points. So we did the x and y. We might use 0, 1, 2. We all use 0, 2, 4. X, y, 0, 3, 6, right? Then the second method we are using is what? Use t-table with how many points? 2 points. Special 2 points, right? 0, 0 for the intercepts. So, however, as you can see, when we use this, what happened? When you use the xy intercepts, you only get 1 point. You cannot make a graph this way, make a line this way, right? So you need to find another point. So the method 2, we are learning to graph the line with intercepts may not always work. So you have to go back to the first method to get another point to make it work. Okay? Let's look at the third one. So we have x and y, right? So when your x is 0, that's your y. So when x is 0, so you have 0 equals negative 5y plus 10, right? So you plus 5y on both sides. You have what? 5y is 10. Then your y is what? 2. Right? So you have 1 point is 0, 2. Right here. Right? Then another one would be when y is 0, what's your x? So your 3x equals negative 5 times 0 plus 10, right? That would be 0, so 3x is 10. X is what? Divided by 3 would be 10/3. So 10/3. Where is your 10/3? You need to change what? The improper fraction to a mixed number to be able to tell. Okay? So you need 3 and 1/3. You pass the 3 and a little bit more. So if we work on the paper, we can tell where it is. So that would be 3 1/3, right? And 0, right? But on the computer, it's hard for us to graph that fraction thing, okay? Then you can connect. But sometimes if you want to use XY intercepts, you might encounter fractions, but the methods are the same. It doesn't matter you have fractions or not. You should be able to graph it, right? So all those examples, you have what? X and Y's, right? So all the points, you will cross the x-axis or y-axis, okay? Then if you look at the next special cases, that will be a little bit different, as you can see. Take a look. So on your page 26, okay, if we have this situation, if we say x equals 5, is this a linear equation? Except y is missing, right? So y is missing. So if y is missing, it means what? Y is free to be any number. Okay? So if we graph it, we use t-table. How does it look like? So what kind of things you have to put in x? It says 5. You cannot put a 0, 1, 2. So you have to put a 5, right? Then how about y? Y is missing, can be anything. How about we put a 1, 2, 3? Can we do that? Okay. So if we graph this one, how does it look like? So we have what? Phi 1, 1, 2, 3, 4, 5. Phi 1, phi 2, phi 3, right? So what kind of line we have? We have a vertical line. Is that right? So that's your x equals 5. Because you have x, but the y, you don't have y. Y is free to be any number, but the y goes up and down, right? So if it goes up and down, it becomes what? A vertical line. Okay? If we have, say, x equals 8, where do you think it is? That would be here, when x is 8. That would be the line, right? If x is -3, where it would be? Would be here, right? And this one, x is 0, so this line is x equals 0. So for vertical lines, it will be parallel to what? Y-axis. Is that right? Right? So those are special cases. And if we look at the next one, if we are going to graph y equals 5. When y equals 5, x is missing, right? If x is missing, it means what? It's free to be any number, right? So same thing as we graph, we will use t-table. So what do you think you would put a y? Y says what? It has to be 5, right? What happened to x? X can be anything. How about just put a 1, 2, 3, right? So if we graph this, how does it look like? So x is 1, y is what? 5. X is 2, y is 5. X is 3, y is 5. Is that right? So you connect this point, connect all those points, it would be what? A horizontal line, right? Because y is fixed and x is free to be any number, x goes what? Left and right. So it becomes what? A horizontal line, right? So this one will be x equals 5. If it's x equals 7 or 8, what do you think that would be? Would be here. If x is -3, what do you think? That would be somewhere here, right? Then x-axis would be what? X is 0. Oops, that's not right. Should be y. No wonder it looks funny. So that would be y equals 5. That's y, because x is free to run. All right, sorry. So that would be y equals 0 for this line. X can be anything, right? So those special cases, what we are talking about is that when your equations have x and y's, it would be what? A slant line, right? Can be slant. But if you only have x or y, you have special situations. One is what? Vertical line. One is what? A horizontal line. Right? So look the next thing we are talking about, say, in general. What kind of situation that would be? If you look at the situation, okay, if we have x equals c. C means a constant, can be any numbers, right? X equals some kind of numbers. Can be 5, can be 8, maybe -3, situation like this, right? Then what kind of line we have? We only have x without y. Y is free to go up and down. Then we will have what? A vertical line, right? Then when you have a vertical line, then you have what? You will have x-intercepts, right? Then you, in general, you don't have a y-intercept, okay? Except this one, you overlap with all the y's, y-axis, right? We are talking about special cases. If regularly you have both x and y's, you will have what? Slant lines, okay? If you have, say, y equals c, means y equals some kind of numbers like this. Maybe, right? 5, maybe 8, maybe -3. Then you don't have an x. Means x is free to run, but when x runs, means go up, left and right. Then, if goes left and right, we will have a what? Horizontal line. Right? Okay? Then, if it's horizontal lines, you will have y-intercept, right? Usually you have no x-intercept, right? Because they are parallel to x-axis, except this particular line. Right? So, we will summarize it this way. If you look the summary, so we are talking about what? 2D world, two-dimensional world means what? Two variables world, right? So if we have both x and y axis, xy variables, then because it's a slant line, right? So you will cross what? X-axis and y-axis, right? If we only has x variable, we only has x variable, so there's no y. Y is running free up and down, right? If you're running free up and down, the line crosses what? X-axis, right? Then if we only have y variable, then x running free left and right, that would be what? Horizontal lines. You will cross what? Y-axis. Think about it, okay? So on this section, we are graphing with intercepts. So we understand what do intercepts mean, right? Then with special cases as well. So that's for our section 4.3.